doubt from week 1, then week 2, then week 3, and so on. Okay. And if you have doubt any questions, so you can raise your hand and ask. So let's start with from week 1. So any one of you have doubt, any question from week 1, so you can ask.
Sir, first of all, we want to thank you, sir. Thanks. You people are very dedicated and sincere.
Okay.
Sir, can you give like a summary for the tomorrow's exam?
Krishna, actually, summary for summary, you can, we have already arranged the, a kind of revision session and all.
Yes.
So you can, if also, so you can rewatch. But this is especially for,
Final doubts. Okay, fine.
Okay. Final doubt you have for whole syllabus, so you can ask. Okay, is this fine? Yeah, so
sir, what is the weightage, like 25%, like all?
No, weightage is from 1 to 8, it's approximately, it covers 50%, and 9 to 12 we will cover approximately 50%.
What, 9 to 12?
Week wise.
Okay, what? How many percent, sir? 9 to 12?
Yeah, it will cover approximately 50%.
Oh, 9 to 12, 50%.
Yes, and from week 1 to week 8, it will cover approximately 50%.
Oh, okay, sir.
Okay, so any one of you had doubts, so you can ask. You can raise your hand and ask. Okay, so from week 2, Anuranjan has asked activity 12.3, question number 6. Okay, so anybody have doubt before week 12, or should I go?
Sir, week 3, we have that association, right? What is that? Whether it is associated or not, that
Correlation.
not correlation.
Covariance.
No. We have to find the percentage. If the percentage
Percentile range.
Okay, so what your doubt? I mean,
Point by serial coefficient.
No, not that one.
No, he's asking about association between variables.
Yes. Can you just touch on that?
Association between variables is actually, you can calculate by it was by covariance. You are talking about linear association or normal association?
We have linear association only in syllabus.
Yes.
But association regarding the contingency table, we have associations.
Yeah. From contingency table, you can calculate the things. Do you have any question regarding that? It was in week 4, right?
Yeah, week 4. Sorry, week 4. Yes. Association between two categorical variables.
Yeah. Let me see.
Yeah. This one only.
Yeah, one second. Let me see that table.
Sir, can we go like rapidly in like conditional probability, these things?
See, we will go with week wise. This is actually open session up to week 12. Means if you have any doubt from week 1 to week 12, so you can ask. Okay. And for summary and all things, you can was
Mock test last question, sir. Mock test.
yeah, one second.
Sir, even in the qualifier and also quiz 1, quiz 2, there was no question on point biserial correlation. So can we expect or can we skip that one, sir?
No, you can expect.
Okay.
Okay. Yeah.
Okay.
See, this is, if you see, this is the table for owning a smartphone. Okay. No, yes, female and male. So see, if your row relative frequency, suppose for all row relative frequency is approximately same. Okay. Then you can say variables are associated or not.
Not associated.
Not associated. Okay. If row relative or column relative frequency, whatever you can calculate both of any one of those. So if these are different, then variables will be correlated.
The only doubt is both is required, or if one.
No. You can calculate either row relative frequency or column relative frequency.
Okay.
This both method is same. If you calculate column, then it will also give the same result by the row. You can use any one of the method.
Okay, sir.
Okay.
So what will be the number of questions we expect?
You can expect around 15. Around 14. Okay, so any one of your doubts till week 3, week 4?
Sir, and also in quiz 2, we had for steps also some marks they gave. Like that in final also will be there, sir?
No, in final
it's not there. Okay.
Yeah. Anybody?
So there is one question in the chat. I mean, asking whether when to use factorial and when to use a combination, because even I get confused between those two. If you could explain something on that note.
Okay. See, factorial is something. Suppose you. Okay. Suppose you have 4 digits. Okay. 1, 2, and 3 and 4. Right? And suppose I have to arrange these 4 digits at some hours. Suppose I have to make numbers with the help of these 4 digits. Okay. And condition is like you can say numbers is not repeated. Okay. Okay. Suppose so at the first place, how many numbers you can take?
4 factorial.
4 factorial.
4. And at the third place, you can take
3.
any of 3 numbers at this
2 and 1.
Okay, that is nothing but 4 factorial.
4 factorial.
When counting is involved, type of and without repetition kind of thing. Okay, numbers, suppose things are not repeated, then you can use like factorial. And combination is something when you have to choose. Means suppose for example you have these 4 numbers. Okay, and I am saying you have to choose 2 numbers. So you can choose in 4C2 way.
Okay.
Means out of 4 you have to choose any 2 numbers. And in combination, order not matter.
Sir, simultaneous and non-simultaneous.
Okay. Simultaneous means something. Suppose this example where and is operating means suppose I am saying I have to make the 4-digit number. Then I will choose the first digit and second digit and third digit and fourth digit. So we are choosing the numbers one by one, means one after the another. This is called something simultaneous. And non-simultaneous means suppose and okay, for example, you have to choose
4 or 3 or 2 or 1.
For example, you have to choose. You can choose without repetition or with repetition. Suppose, for example, for with repetition, it will be 4 into 4 into 4 into 4. Okay. But for this B pattern, especially it is simultaneous. But suppose I'm asking, you can choose either A or B. Means at a one time, only one thing will happen, means A or B. That is non-simultaneous.
Okay, sir.
Okay. Simultaneous means and will be applied, and operation will be applied, means these things and these things and this thing and this.
Sir, and means multiplication, or means addition, correct? No?
Addition, yes.
Okay.
Excuse me, sir.
Yeah, please.
So in earlier we discussed about combinations. If we have to choose two numbers out of four numbers, we have given 1, 2, 3, 4. If we have to choose two numbers to form a group of numbers, we have to form a number like 42, 34. Then we will use permutation because their order will be matter.
No. It was just it was just for choosing. I'm not going with the number, framing the numbers. Okay.
So if order matters, we have to use
Then,
permutations. No?
Yeah, then permutation.
And then if order is not doesn't matter, we have to use combinations.
Yes.
Yeah.
And see, if the question is like you have to select, you have to choose, okay, you have to, then selection is something. Then if, and with the order condition that order is not matter, then you will use the combination.
Okay, sir.
Okay. In permutation, order matters.
Okay, sir.
Okay, I think you guys
can we move to the
one by one?
Sir, is it possible to touch on permutation one more time, sir? Permutation and combination, how to quickly distinguish? Is it possible to repeat? If
okay, one second.
Thanks, sir.
Okay, first of all, tell me, any of you have doubt? Any question till before?
No.
Sir.
Okay. See, you know what is permutation? Meaning of permutation?
Arrangement.
Okay. Arrangement of what? Ordered arrangement.
Yeah.
Okay. Ordered arrangement of, suppose whatever you have objects. Okay. So ordered arrangements. Okay. Suppose please order is matter in permutation. Right.
Yes,
suppose I have to make the permutations of an objects. Then in how many way I can do? In n factorial. If I'm asking that objects are not repeated, means without repetition. Okay, that means suppose you have n objects and you have to the previous example, you have 4 digit 1, 2, 3, 4, right? And I have to make the a number of 4 digit. Okay, with without repetition. That means it can be 4 into 3 into 2 into 1. That is the 4 factorial. Okay.
Okay.
It is also you can say permutation, because if you do if you do 4p4, right? That means 4 factorial divided by 4 minus 4 factorial, whatever it will be
4 factorial.
4 factorial. And suppose if I'm asking with the help of these 4 digits, I have to make the number of 3 digits. Okay, then what it will be? 4 into 3 into 2. Again, it will be 4 factorial, right?
Yes, yes.
But if you do 4p3, means 4 factorial divided by 4 minus 3 factorial, again it will be 4 factorial. So these things either you are doing manually or with the formula of permutation, it will give the same answer.
Now it is without repetition. With repetition.
Yeah, it's about without repetition.
Okay.
Okay. Suppose I'm asking about the with replacement. with repetition. That means at the first place it will be 4 and 4 and 4 and 4. So it will be 4 raised to power.
Okay.
This is the something. Right? So the previous formula, I mean, this NPR equal to, it will be n factorial and n minus r factorial. It's for without repetition. Okay. And n raised to power r means it will be with repetition. N means r means it's repeated r times, right? Okay. So yeah, this is for permutation. And combination is where you have to choose. Suppose you have an object, okay, and I have to choose the r objects. Okay, I'm not concerning about the, you can say, order. I have to just choose, I have to just select. Okay, then it will be NCR, means n factorial divided by r factorial into n minus r factorial. See, if you clearly observe these things, r factorial into NCR equal to, it will be NPR. This thing, right? Hello.
Yes, sir. Yes, sir.
Yes, sir.
Clear? So what is meaning of this? First, you are choosing the r objects from the n objects.
Yes, sir.
And then you are arranging those r objects in r factorial ways.
Okay.
That is the NPR.
Okay, sir. Sir, can you move a little bit upward and that permutation part?
Previous one?
Yeah, just a second, sir. First one is without repetition, right?
Yes.
Okay, thank you, sir.
Sir, I have sent a question in chat box. Please explain it.
Sir, we request you to quickly move towards week 9 and for the
yes,
because they have the more weightage.
Yeah, one second. Ujjain questions had already discussed. Not
yes,
this
sir.
lecture.
Yes, sir. But I don't get it.
Okay, I will tell you. Okay, so Krishna, I think Krishna has asked about this permutation combination things, right? Hello.
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
So it's clear, or should I?
Yeah. More or less clear, sir.
Okay. Let me give one more example. After that, yeah. Say suppose
sir, you are telling that some exam question was discussed. When it was, sir? If you don't mind.
No, I was not told. For example.
Oh, okay.
Say suppose you have 3 objects A, B, and C. Okay, and suppose I'm saying I have to choose 2 out of these 3. So what it will be? 3C2.
C2.
What will be 3 factorial, 2 factorial into 1 factorial means 3. In combination, you know, order not matter.
Yes, sir.
Okay, so this is something combination means it will be AB, it can be BC, and it can be AC or C. Okay, so this is for combination. Suppose I'm asking for permutation, means when order matter. Then what? When order matter, that means AB is different from BA.
Yes. And CB
BC is different from CB, and AC is different from CA, right?
Yeah.
So if you do permutation, that means 3P2, or suppose with the help of these 3 alphabets, you have to make 2. That means 3 into 2, it will be 6, right? If you see, if order matter means AB is different from BA, BC is different from CB, AC is different from CA, then it will give you 6 combination. Okay, 6 possible pair. But if you do combination, means order does not matter, means AB is same as BA, BC same as CB, AC same as CA, then it will give the 3 pair, which is combination. So it is clear how order matter or not?
Okay.
Yes, sir.
Yes, sir.
One doubt here.
Yeah, please.
See, suppose if the person has to be arranged, then it is an order matter. But if the object like a car or chocolate or something to be arranged, is it order matters or?
No, don't go with that like car and things. Just think whether order matters or not. It can be anything like. Okay, it depends on the what is concerning your question.
Okay, suppose that's what there was a question like the car has to be arranged or chocolate has to be arranged. So is it order matters or doesn't matter?
Actually, I said no. It depends on the object of the question. Suppose I'm saying for chocolate, it can be like I'm saying suppose dairy milk. It's I have to arrange first, then after munch and.
No, also same kind. Okay, same. Like...
Okay, then same kinds. So I don't think order is matter.
Okay.
So it can be same for car also.
Okay.
Suppose I go in the showroom and I have 10 cars. Okay.
Yeah.
Of the same kind, and I have to choose one car. So I can choose any 10C1 car.
Okay, got it.
Okay.
Sir, can we discuss that question where we talk about something raised to power something, that question?
Something raised to something means?
When there is some event and then we talk this many has happened, so we raise to some powers, like that question.
Can you repeat? Actually, I did not get your point.
Like there was some question, sir, when event happens and we just raise it to some powers and the number of events to the base, that question. In combination, it is in commutation and combination, sir.
Okay, you are asking about like with repetition.
Yes, sir.
Okay, see.
Yeah.
I had explained this one.
I got that, sir. It was some different question, I guess. Like something like when there is something only true event, and then we just take it as true, and the number of how it's happening, we raise to some powers. Yes or no? So that's it.
Okay. Can you tell me the question?
You can just explain with any example. I mean.
Okay. So do you remember that question? Like you have to attend, a student has to attempt a paper in which there was 6 questions of true or false type, right? Okay.
Yes.
So in how many possible ways he can attempt the question paper? Okay. So can you tell me for one question, how many ways are possible?
2 ways.
Sorry?
Yeah, 2 ways.
2 ways, either true or false.
3 ways. I'm asking about the attempting the question paper.
Oh, okay.
Okay. Not saying like in how many ways he can answer the question. That kind of thing. Suppose you
Sir, it is not attempting or attempting, only 2, na?
No. See, you have one question. It has already 2 ways, true or false. Okay. If you attempt, then you can do anything, true or false. That means if you take the false, then you also attempt. If you do the true, it also attempt. Okay. But there is an option for not attempting. Right? Then okay. Suppose you gave the quiz 2 paper, all of you. You had how many questions? I think 19. Right? Suppose I'm saying how many questions do you attempt? In how many ways you can attempt? So you have 3 options. Either you can prove, you can do false, you can do not attempt. Okay. Then you have to 3 way for first question. Is it clear to everyone?
Yes, sir.
Yes, sir. Okay. Similarly, for the second question, again you will have 3 way. Similarly, for the third question, you will have the three way and up to 6. That means first question you have three ways, second question you have three ways, for the third, for the fourth one, for the fifth one, for the sixth one, that will give the 3 ways for 6 ways. Is it clear to Rabitan?
Yeah, yes, sir. Okay.
So just think what is the objective of the question. Okay.
Sir, for multiple choice, then it is.
Suppose for multiple choice. Okay. And you have 4 MCQ. Okay. Then you can choose any 4 options. Right?
Okay. Yes. Sir.
But see, if the
And
question,
I will not attempt also, no? Five.
Yeah.
5.
But if the question is asking about the attempting, then you can, then you will have the 5 options. Otherwise, see, I'm saying just answering the question, you will have the 4 options for one question.
Okay.
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 There is a difference in how many ways you can answer the first question. You have only 4 ways for answering the question. You can take the first option, you can take the second option, you can take the third option, you can take the fourth option, any one of the options. Okay. But I'm asking attempting, then one option will be at type you cannot attempt the miss. You have one option that you cannot attempt that question. Clear?
So when we have a specific keyword of attempt, we add the not attempt of another option. Otherwise, we can choose it as just the number of answers. Okay.
It depends. It depends on the question. What is the answer?
Okay. Sure.
And
Okay.
more than one answer is also accepted then, sir.
Then there is a question. I don't know, remember exactly week. Yeah. Suppose it's MSQ. Okay. Then you can choose one option. Okay. Or you can choose 2 options, or you can choose 3 options, and you can choose all of the options. These will be number of ways to attempting the, to answering that option. Then see, it depends on the question. I said no. It asks you, then answering a way of answering the question will change, and this MCQ it's changed, and it's already true first type of thing, it's also changed. Right? You got this one? You can
Sir.
choose one option.
If there is 10 questions, then 10 into this much, right?
Yeah. Yeah. 10 into this way. No. One here. No. Suppose you got the, what will be this one? It will be 4. It will be 6. It will be again 4, and it will be 1. It will be 15. Okay. So you have 15 ways for one question, right? And you have to, then you will have 15 ways for second option. You will have the 15 ways for the third question. Similarly for the 10th question. Okay. So it will be 15 ways for 10.
Okay.
Okay. If you attempt all the, if you answer all the questions.
No, sir, if it is attempt, then we require to add one more, 16 into 10 power 10.
Okay, so anybody else, any doubt in the question of week 5, week 6, week 4, week 3, week 1?
Sir, in this, we have to take for correct and for wrong separately, no, sir, for each question.
Yeah, it depends. For this is the for correct one. Okay? No.
Then we have to take also for wrong ones also, sir, for each question.
These are the total way for answering. Okay, but for correct way, for wrong way, there are 14 ways. Because there will be only one way in which question is correct. Okay, then for wrong, it will be 14. Got it? Okay. Suppose you have 15 ways, you can attempt, you can answer that question in 15 ways. and only one way will be correct out of those 15 ways. Okay, that means the remaining 14 ways are wrong. Okay.
So for multi-select, it will be different, no, sir? For each question.
It's it is talking about the multi-select question. And for multiple choice question, when you have to choose only one option, okay, then for attempting the for answering that question, you have 4 ways. Okay, and only one way is correct, which will give the question correct, and remaining 3 ways is the
wrong.
That is this.
Sir, please explain base.
Base one. Okay.
So actually, I have one doubt on this.
Yeah, you can ask.
So like there was this question that you have given word Madras and you have to a number of ways without repetition, and the word the alphabet D has to be in the middle. So whether we will repeat the A or not, because in the word it comes 2 times.
Okay, it was on, I think, quiz 2, right?
Yes, I think so. Yes.
Okay, so
can
you send me the question?
So actually, one of the student has given in the chat. It was similar to that.
This one, Ujjain one, is right?
Yeah, it's similar to that.
Okay, in how many 3-letter words without meaning can be formed using the
In that
letters?
Madras, D is fixed at the 3rd position, I think. D is fixed at the 3rd position. And how many ways we can arrange rest all letters? Madras, M-A-D-R-A-S.
See, this is Ujjain is given, right? And it's said that with or without a meaning, we have to form the 3-letter words. Okay, and such that alphabet I is one of the alphabet in each of the word form. Okay. Okay, Madras. Yes, in Madras, for the Madras question, there was some mistake, I think. Mistake in
I have
the
posted the question in the chat.
Yeah, I saw. Actually, in this particular, there was a mistake in the answer one. So we have gave the marks to all of you who have attempted this question. Okay.
Okay, but
okay.
So just to
But yeah,
can you explain what is the mistake, please?
Actually, mistake is about there was a lot of cases for attempting that question. Okay. But we somehow
yeah, please explain. Correct. What is the correct answer?
Correct answer is something Madras one, right? Okay. D is at the 3rd place. Then there is there will be a lot of cases like what is the question? Without
That's
meaning.
it. How many ways we can arrange?
Yeah, such that the alphabet R occupies the 2nd position, moving from left to the right. Okay. How many letter was there? Yes. How many words? Okay, it's not a. Okay, see, R occupies the 2nd position. Okay, then 3, 6 is there. Okay, right? R at 6, that is 2nd position, right? Then you have to.
Is this the editor mark question? I didn't remember R is also fixed. Is this the editor mark question?
No, it's not.
For every student, it is somewhat different. So
no. See, there was set 1 and set 2.
Okay, for me, D only fixed.
Yeah.
Okay.
So, some of you have attempt like 6. Okay, 6 factorial divided by 2.
Why 2? Prashant, then this is, see, for me, the question is easy. Only D is fixed. This question is difficult. D and R both are difficult.
No. Only R is fixed here. If you see the question.
Okay, fine. Right.
Then how many letter words do we have to make? How many letter words?
Yeah, please give me words.
So then we have to words?
Do 1 second. Yeah, see, you have to form the letter, you have to use all the letter, okay, in that question. So you can see, there will be cases like A can be different, okay. A can take, suppose I'm saying, in general, in how many ways you can arrange?
It's 5 factorial, right.
5 factorial, okay, because A is repeating, then it will be by 2.
Yes. This is correct answer, right?
But there are more cases.
Sir, because we had fixed R, so we are using R 5 factorial, right?
Yes. Okay, there will be more cases. Just think about it. What can be the cases? That's why we have given the marks to all. Okay, but this is the wrong.
So it will be like you can make 4 letter words and 3 letter words also.
Sorry?
You have to add the 4 letter words and 3 letter words also to that.
Yes. Kind of.
Okay, here question is not saying how many letters word is needed.
Okay, so let me clear this. Okay, so who has asked this one? Jen question?
Me.
Okay. Where it was? I think it was in ma'am has
revision
yeah,
session.
ma'am has revised, right? Okay. 1 second. We go back.
5 to 7.
5 to 6
Supplementary. Yeah. Revision session. Yeah, first one. No. Yes, second one. Yeah.
Well, ma'am, have you watched that lecture?
No, sir, no.
Okay, that's why
I missed that.
Okay, just see this one. Here, solution is clearly explained by us. See, if you see, how many 3-letter words with or without meaning can be formed using the letters of the word Ujjain without repetition, okay, such that alphabet I is the one of the alphabet in each of the words, okay, and you have to form the 3-letter words, right?
Yes, sir.
So tell me, initially you have 6 letters.
Yes, sir.
And for it is fixed that I will be the one of the alphabet, okay. Then at those 3 places, in how many way you can arrange the I? 3p1. 3p1.
Yes,
that is 3.
Yeah.
Okay. Then tell me. There will be cases like, first case is, suppose you have 2j, right? First one is, J is not used to form the 3-letter words. Suppose you have 6 letter, okay? You 2 times J, A, I, N. Okay. Suppose I'm not considering the J. Then I have U, A, and N.
Yes, sir.
Okay. With these U, A, N, and I will be there. It is fixed.
Yeah.
Okay. And without repetition, it can be 2 in 3p2 way. That means 3 into 2. Okay. See, suppose I'm saying Ujjain. Okay. And in the question, it is says that I will be there out of in those 3 letters. Okay. Then for these I, in how many way you can arrange?
3p1.
that is 3, or you can say 3, any of 3. Okay, so I will be there. Okay, suppose I'm concerning the case where J is not coming. That means you have U, A, N, right? And
Yes, sir.
you have to form 3-letter word. Okay.
Yes.
And in at any of the place, I will be there.
Yes, sir.
Okay.
And 2 place will be
2 place for the
available.
UAN. That means
yes, sir. 3 into 2.
3 into 2, or you can say 3P2.
Yeah.
Okay. And for I.
Yeah.
Okay. This way. Similarly, if you go,
Case
when
2,
J is used once, because you have 2J, then you can use J. Suppose I'm using the J only once. Okay. Then number of ways to J in the 2 places is 2P1.
Yes, sir. Yes.
Okay. Suppose you have 2J and I'm saying that I have to use J only once. Okay. And I had 3 places. Okay. For I have 3 ways, and for J, see, J occurring only once means J will take only 1 place. Either this, either
Yes,
this. No,
yes.
no. Any 2.
Only 2 place.
Because suppose I take this one. So
yes.
J for J is 2P1. Is it clear?
Yes,
and you know I has already occurred 1 place, J already occurred 1 place. Then this remaining word UAN can take 1 place.
Yes, sir.
Clear? Similarly, when J is used twice, means you have only 1 way. Means suppose suppose you have 3 places. Okay, I will take later I will take any of the place. Suppose I took the place this first one. Okay, then when J is used 2 times, then it can, you will do only 1 way, because if you change this one, it will not matter.
Total 3 times. 3
okay, it will be 3 into 1.
Yeah.
And finally add all the number of ways.
Yes.
Got it?
Yes, yes.
Here we are forming
Thank you so
3
much.
word letters.
Sir,
Yeah.
for the 5th problem and 6th problems are the same, but the solution is the different. Could you please go through the 5th one also?
5th one?
Same, just word is different.
No,
but
sir, they are not same.
They are not same.
See, in the question, Ujjain, if you see, it's without repetition. Okay?
Oh,
And
sorry.
in this
Fourth one. Sorry. Fourth one.
Okay, how many 3-letter words without me can be formed using the, see, in this vertigo, there is no letter which are 2 times. All are different. Okay. So here is a simple trick. I can take any 3 places, that means 3P1, and all the letters are different. That's why remaining 6 letters will be arranged in 2 places, that is 6P2. But in that Ujjain one, you have J which occur 2 times. Okay, you don't know for rest of the J. Means which J occurs, which will not occur. Are you getting? Here you can do the similar way. Suppose
I didn't got this multiplication part, that why we did 3 into.
Why?
Yeah.
Why not? See, you have to make 3-letter words. Okay.
Yeah.
And in it is condition is there, like I will be one of the alphabet.
Okay.
You have to consider this one, and remaining 2 places you have filled, right?
Yeah.
So it occurs simultaneously. Means I and you have to fill the remaining two places. Okay.
Okay, sir.
See, word vertigo is there, right?
Yes, sir.
And it is condition that I is fixed it at any, I will be there at any of the places. Okay, that means this three way and rest of the two place you have to fill, right?
Okay. I got, sir.
Got it. And
Okay.
see, in Ujjain, I don't remember her name. See, we cases that we consider the different cases because see, you don't know which J will occur or not, right? That's why we consider, yeah, case one, when J is not there, then we have to take these four letters, and when J is occur only once and J is occur two times. That's right. But here, suppose I'm you can do like I, then is there any point to consider first three letter or last three letter?
So
Does make this sense?
every letter is different.
Every letter is different. So for I can arrange at in three way, and the rest of the two places I can make at like 6 into 5.
Okay, sir.
Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay. So any question from?
Let's quickly move forward.
Someone has asked for I think base question.
Yes, sir. Yeah, I was asking.
Yeah. So can you tell me the question? That question.
Please do. There is a question about the teams, probability of the teams. Three teams is given, and we find out the probability for knockout of any team, something like that.
Your voice is not clear to me.
No, sir. Hear me, sir, now.
Rick?
Sir, am I audible now?
Yeah. Now it's more better.
Question, sir, on Bayes theorem.
Mm-hmm.
These two, the probabilities for three teams is given, and we have to find out the probability for one team to go to knockout or something like that.
Okay.
There is a
can
problem
you
in Bayes theorem and conditional probability. Can you give me a short, like revision type, a short overview?
Yeah. Rishabh, this is, you can ask any question from anybody. Yeah. Can you paste the question, that question, or should I give the basic idea if you want?
Give, just we will see that.
How to attempt Bayes theorem, right?
Yeah, sir. A basic overview, sir.
Okay, see. Bayes theorem is something, suppose.
Sir, please start from total probability, sir.
Okay.
So can I ask a small question?
Yeah, Rishabh.
So if the variance to be the maximum for any binomial random variable, the probability will always be half?
Yes.
Okay.
So suppose you have this sample space as S. Okay. And in this sample space, suppose I'm saying, suppose this four events are occurring. Suppose this is F1, this is F2, and this is at F3, this is at F4. Okay.
Yes, sir.
Then suppose, can you tell me what will be this one? F1 union, F2 union, F3 union, F4? S. Then what is the meaning of this one? Means it is mutually exclusive and exhaustive. Okay, yeah. That is the meaning. And suppose an event, let me take as E. Okay, this event is as E, is occurring. Okay, any event it can happen. Means out of the whole sample space, you have these four conditions, and any event E has occurring. Okay. So can you tell me one second. Any one of you, what will be how E will occur? How you can get the E, this event E? Anyone?
Intersection.
It
See,
will be the sum of the intersections.
these things, okay, and or sorry, these things or these things or these things or this thing, right? That means when E will occur means E and F1, okay, or E and F2, or E and F3, or E and F4, right? Okay.
Yes, sir.
Now till this point is clear to everyone how E will occur.
Yes.
Okay. One second. See, if you go with the probability thing, then it will be probability of E and F1, and union will be plus, right?
Yes, yes.
Why it will be plus? Because
it's union.
Union and these events are mutually exclusive.
If one occur, other will not happen.
Okay, and you know, mutually, when events are mutually exclusive, then A union B is same as the probability of A plus probability of B. Okay. Then now let's move. Probability of E. What was this one? E and F1 plus E and F2 plus E and F3 plus probability of E and F4. Okay. So can you tell me what will be this quantity? E and F1? Anybody?
Probability of E given F1 has occurred into probability of F1.
I'm saying E and F1. Okay. So I'm asking about this area.
Sir.
What is this area? Means?
Sir, we can add all this and minus with E.
Minus with E?
We can add E intersection F plus E intersection F3 E intersection F4 minus with E.
No, this is not. No. See, listen to me. What is E and F1? This area, this region?
Yes.
Right? So what is this? How it will happen? Means your F1 has occurred, right? Okay, that means now that means probability your F1 has occurred and probability of occurring E in F1. This is something conditional. Means probability of E given F1 will be probability of E and F1 divided by probability of means see F1 has occurred. Okay, F1 has occurred. Then what is the probability that E will occur? What is the probability that E will occur? Okay, means this common region divided by whole region. That is the something probability.
Excuse me, sir. But here we are just talking about the portion of E, not the whole E.
No.
But the portion which is overlapping with F1.
That's why intersection is there. It is the asking about the probability in the F1 region. Means see F1 is given. Okay, so your new sample space is this F1, right? In this given F1, what is the probability that E will occur? So E will occur only this black region, right? So what is this? E and F1, common region of F1 and E.
So is there any way to just to signify only the proportion of E, which is overlapping with over the F1?
It's a overlapping, right? This black region is in F1.
Yes.
Okay. See, are you getting this point?
Yes,
I
I'm getting this one. But when you are saying E, that means ki complete oval shape.
No. See, what is, try to understand the meaning of this probability of E given F1 means when something is given, that new sample space will be your F1, right? You have asked about this in this given F1, this first block, what is the probability of occurring E? So for occurring E is only this region, this black region.
Yes, sir.
Okay, then how you will calculate? Means this favorable cases divided by whole cases. This is something probability. So favorable cases is E and F1.
Yeah.
And whole case is probability of this F1. Okay. So for this E and F1, you can multiply this two.
Yeah. Yes.
And similarly for E and F2, what is F2 has occurred, right? What is the probability for E given F2? Probability of E given F2? Let me get this one.
It's same probability of E intersection F2 by probability of F2.
See, probability of E given F2. Try to understand the meaning of this one. Means F2 has occurred. Then what is the probability of E occurring in it? That means this blue region. Okay. So your favorable cases will be probability of E and F2, and total cases is probability of F2. Is it clear?
Yes, sir.
Okay. So then what is the probability of E intersection F2 will be these things multiplied by this thing.
With this.
Is it clear to everyone? Similarly for F3, similarly for F4.
This is total probability.
Yeah. That is.
Sir, in total probability, we just know that it has already occurred, and we ask what is the probability of happening that, right?
See, you will given the whole things, okay, and there will be some mutually exclusive exhaustive cases, means like F1, F2, and F3, which will cover the whole sample space. In those events, suppose any events will occur, then what is the chance of, if you go with this Venn diagram, then what is the chance of this occurring E in these four? So you have to consider, suppose occurring of E means in that partition, okay, into probability of partition has occurred and that probability which you have.
And in base theorem, we know just which has already occurred, and we ask about the probability of that, right?
Yes. And first, let's try to understand this one. So what will be this? What is the probability of second?
F2 into probability
F2
of
has
E.
occurred in this probability of this event.
Probability of E F2 has when F2 has given. Or
similarly,
occurred.
You will get these things.
Yeah.
Okay. So this is something law of total probability. Okay.
Okay. This whole thing, sir.
Yeah.
Sir, here E has not already occurred, right?
No, is not.
So
you have to find the probability of occurring E. Then that's why, see, what will be the cases? Suppose I have to find the occurring E, means probability of E means E occurring of E and in F1, or E can occur and in F2, or E can occur in F3, or E can occur in F4. So you have to consider all the cases. Okay. So and you can know, you will know how you can write these things. Okay. Or you can simply interpret like, for occurring E, first things has occurred. You have to find the probability first thing. you have already found these things. That means these things is given. Then in this given region, what will be the probability of occurring? Right?
So it will go till n.
Yeah. How many events are there? It will be suppose only 3 is there, then it will go up to 3.
Okay, sir.
Okay. And suppose I'm asking about what is the probability of, suppose I'm saying event E is has occurred. Okay. And what will the probability that it will occur in F2 or F1, for example? Try to understand. Event E has occurred already. What is the probability of occurring F1? Means probability of F1 and E divided by probability of E.
Yes, sir.
Yes.
Okay. And you know how you can calculate this on F1 and E? How? These things? Okay.
Yes.
And what is the probability of E? As this is the same thing. Means summation I probability of Fi into probability of E given Fi. This is the nothing but the Bayes theorem.
Just a second, sir.
So one clear distinction is, sir, in total probability, E has not already occurred, and in Bayes it has already occurred. And we know
it will
ask the path, right?
Yes.
Okay.
Okay, sir. The only difference is we are in Bayes theorem we are finding the probability of F1 and F2, right?
Yeah, it can be F2, it can be suppose I'm asking my event E has already occurred, then what is the probability that it is occurred in F3 or F4 or Fn, whatever it is.
Okay, sir. In Bayes theorem, event is already occurred.
Yes,
right?
yes. Suppose I'm saying event E has already occurred, then what is the probability that it will occur in F2? Then it will be F2, it will be F2, and it will be F2. Denominator will be same.
Okay. Yes,
Okay. So any question till week 8? So this is the actually open session for.
There is one question in the quiz 2. Can I ask you about that?
In quiz 2, right?
Yeah, that is the area of the rectangle.
Okay.
Sir, as you said in the previous example, is it concerning to that question where the two factories producing some product and the different there is different probability of defective product?
Actually,
And
Ramnaresh, CC,
okay.
I not remember that question, but I have to see that question.
Okay. No, I'm just correlating with the problem space to the explanation.
Okay, you can correlate actually. Just see, whenever you have given the question, just write the events, okay, and probabilities, whatever you have given in that question, okay. Then you will get the idea. Like suppose in the end of the question is like something. Yeah, these things has been all occurred. Then what is the probability that a part of occurring in it? Then Bayes theorem will be used. And suppose it's given like these things are given, okay, and I'm asking about this only this probability, then law of total probability is used. Okay, so you can post on the, I think this one, or discussion forum also. Okay, I will take. Yeah, I think this question has been discussed. Yeah, but I will. Yeah, sum of length and breadth of the rectangle is 12. Find the probability that area of rectangle is not less than 3/4 times the greatest area. Okay. See, see, sum of length and breadth is 12, right?
Yes.
And asking about the greatest area is only when length is equal to breadth. Okay. And you know what is the area of rectangle?
L into
B.
Yeah.
Okay. I can write it L into 12 minus L. Do you know differentiation thing?
Yes, sir.
Okay. So can I write it at 12L minus L square?
Yes.
And what when the things is maximum? I have to differentiate this area with respect to L and put it 0
at the line of symmetry.
Okay, so it will be 12 minus 2L equal to 0. Okay, are you getting this point or not?
No, I'm not getting it.
Okay, do you know about this differentiation thing?
Differentiation, no, long that I done, but I'm not sure.
Okay, you are not sure, right?
Yeah.
See, let me
But
go
if
with.
we divide it by 2, then we will get the maximum proportional way. I mean, 12 by 2 is 6. So if length and breadth is 6, the correct.
You know, L into B is the area of rectangle, right?
Yeah, correct. Yeah.
Then question was how many it was. It's not less than 3-4 times the greatest area. Okay, that means it is greater or equal to 3/4 times the greatest area. Okay,
Correct.
it's the greatest area. Okay, so how you will get the greatest area? In the question it is said length should be equal to okay, and length plus breadth is 12, so length breadth equal to 6.
Yes. Yeah.
Okay, so L into, and in the question it is given that this things L plus B equal to 12. So can I write at in the place of B as 12 minus L?
Yeah, correct.
Greater or equal to 3/4 times greatest area will be 6 into 6.
Yeah, correct.
Okay, because area is something length into breadth.
Correct. Yeah.
Okay, and it will be maximum when L equal to B. That means L equal to B will be only one case when it is equal to 6. And see, from the previous one, you can also get the 6. 12 equal to 12, that means L equal to 6.
Yeah, that
okay?
is, yeah, correct.
So, see now, I write it as 12L minus L square greater or equal to 3/4 times 36. So it will be 9. It will be 12L minus L square greater or equal to.
How the square has come?
7.
See, this L, 12L, and this L into L.
Okay, got it.
Got it? Now, can I write this one? 0 greater or equal to L square minus 12L plus 27. Means these things replaced with this thing, this side, right?
Okay.
Now, can I write these things? 12L square minus 12L plus 27 less or equal to 0.
Okay.
Okay. And you know this factorization things. I can do like 3L minus 9L plus 27 less or equal to 0. It will be L minus 3 minus 9, L minus 3 less or equal to 0. It will be L minus 3, L minus 9 less or equal to 0. Okay. Now you have to think. See, you have region from maximum region 12. Okay. Suppose 3 is there and 9 is there. Okay. Then tell me, see what is meaning of this? Means product of these two should be 0 or negative.
Less than.
Right?
Yeah.
So can you tell me if things are less than 3? Means suppose minus, suppose I'm taking as 2. Then what will be this will give? If you put L as 2, 2 minus 3, 2 minus 9, it will give minus 1 into minus 7. It will give you a positive things.
Yeah, okay.
Means less than 3, you are getting the positive.
Yes.
And go for this between the 3 to 9. So suppose take at 6. Okay. Suppose I'm taking a 6. So it will give you 6 minus 3, 6 minus 9. So 6 minus 3 is 3. 6 minus 9 is minus 3. It will give you minus 9, which is less or equal to 0.
Yes, sir.
That means in this region, you are getting negative. Now, 9 to 12. Suppose I'm putting as 10. Okay. So what will be this? 10 minus 3 is 7. And 10 minus 9 is 1. It will give you 7. That is the greater than. That means this region is give to positive.
Yes.
And but the condition is what? Things products should be negative. Okay. Then if you see out of 0 to 12, this half region is give to satisfy this condition.
Yeah, so the 3 to 9.
Okay. This is the half one. That means there is only 6 things. And remaining 3 things are there. 3 things are there.
Okay.
Okay. So only this half things satisfy this condition. So probability will be
3 by 6.
1 by 2. Half. Only half things are satisfy this condition.
Yes, so 6 by 12, so 1 by 2.
Yeah, you can do just 12%.
Okay.
Because you have possibility till 12 and you are doing only 6.
Yes, sir.
Okay.
Yes,
so is it clear to everyone?
Yes, clear.
A great way to explaining.
Sir, can so
Sorry?
which week
It was a great way you
Okay.
explained.
Okay. Yeah, please go.
So we are in week 9 or 10?
No, see. It was this session is for any week. You can ask any questions.
Yes, sir, because I want some questions. I want some discussion about exponential binomial random variables.
Okay. So initially, someone has asked 12 point question from 12.3. Is there or not? Who has asked the question? Yeah. Arun Rajan, is there? Hello.
I think he left.
Okay, he has asked question 12.3, question number 6. Okay, let me cover that one. Yeah, so any one of you have any doubt from week 12 in any questions you can ask. I think he's not there, and how can I?
So mock end term question number 15.
Yeah, Rishabh, there was a mock session which conducted by Isan sir also.
Oh, okay, sir.
Okay, so you can rewatch question number 15. Yeah, so any one of you have doubt? So you can ask,
Sir,
or you
all
can
the
raise your.
mock questions
So
not solved,
8.7.
sir.
Sorry.
All the mock questions are not solved. Only some questions they solved.
Yeah, but there was session you could ask, right?
No, I think almost all of them was solved.
And see, there is mocks solution has uploaded, so you can watch.
Sir,
Okay?
the pattern will be same as mock test.
Yes, timed mock. Timed mock pattern will be similar to timed mock.
Sir, I have a question.
Please.
In exponential function, when we are writing the expectation of x to power n, somewhere I think we wrote it is equal to n by lambda into expectation of x n minus 1.
1, yes.
I didn't understand that.
Oh, see, that was the when you integrate the things, that quantity you will get.
Okay.
I will I will come to the point. Yeah, someone has asked activity 8%.
Third question, sir. Third question.
After that, I will come to point, Divya. Okay.
Sir, is
All
week
right.
sir, is week 12 is most important? Like,
no, you can't say like most important. I said clearly, week 1 to week 8 will cover approximately 50%,
yeah,
and the
sir,
week 9 to week 12 will cover approximately 50%.
yeah, sir. Because due to the lack of time, I was not able to cover week 12, so that I was at.
But I think you can cover today also. It will not take more time. There is only, I think, two distribution, uniform and exponential. Okay. Yeah. See, who is this? Yeah, there. Yeah. See, in the question it is given that motor. You can define event like. See. I can define as X. I'm taking event X as motorcycle X. Motor X is chosen. Okay. And Y, motor Y is chosen. Right.
Okay.
And you can define for good mileage. I'm taking as M. Okay. For good mileage. Okay.
Okay.
See, in the question, if you see, it is given that probability that motorcycle X has good mileage is 0.5. Means probability that of being good mileage given that X motorcycle
Yes.
is 0.5.
Yes.
And next thing is,
Sir, I have a doubt whether it is M given X or X given M.
see what is question? What is question? Probability that motorcycle X has good mileage. Try to think. X thinks it's given, right? Are you getting?
Yes, sir.
No,
Yes,
sir,
yes.
not got.
See, what is the probability? Probability that, so suppose I'm saying you have two motor X and motor Y. Okay. And I'm saying motor X has probability of being, motor X has good mileage is 0.5. Okay. So, you know, I'm telling about like motor X is given. This motor X is given and probability of good mileage of that motor is 0.5. Getting?
Okay, sir. Right.
Right. I'm saying you have two motor X and Y, and I'm saying probability of good mileage of this motor. Probability of good mileage of X motor is X is 0.5. Getting or not?
Can you please make some kind of Venn diagram?
Okay, see, suppose. Suppose you have this X motorcycle and Y motorcycle. Okay, and suppose I'm saying mileage is M as an event, right? Let me write down the X and Y as outside. Okay, this is the X, this is the Y, right? And mileage is something which is for both two. Okay, and I'm saying probability of motor, probability of my what's the question? Yeah, probability that motorcycle X has good mileage is 0.5. Okay, I'm saying this motorcycle as X has occurred means mileage for this motorcycle X is 0.5. Okay, mileage for this motorcycle X is 0.5. Are you getting this or not?
Yes, sir.
Yes, sir.
Got it? See, I'm saying mileage for X. What is mileage? Mileage is this one, and mileage is this white region is for Y. Let me put it as red region. Okay, your motorcycle X is here, Y is here, mileage, this green region is mileage for X region, and this red region is mileage for Y region. Right? Is it clear or not?
Yes, sir, it is clear, Anjana.
Okay. Similarly, in the question, it said that say this, what is the probability is given? Probability that motorcycle Y has a good mileage is 0.7. Means motorcycle Y has a good mileage and probability of good mileage for Y is 0.7. Clear?
Yes, sir. Understood. Go ahead. Yes.
Got
Yes,
it?
sir.
Got it this point?
Yes, sir.
Okay. And can you tell me, it is asking about that question, motorcycle is chosen at random and probability that motorcycle has a good mileage. So for being the good mileage means you have to find the probability of M.
Yes.
Then how, what will be there? Law of total probability will be applied here?
Yes, sir.
Okay. Means separate things, sub parts is there and you have to find the this M. Okay. Then tell me how you can calculate the M. Means probability of M and X or probability of M and Y, because M is the good mileage. Okay. And then the question it has asked, a bike is chosen means a motorcycle is chosen at random, means it can be X motorcycle or it can be Y motorcycle, and you have to find that it has the good mileage, means good mileage and motorcycle X or good mileage and motorcycle Y. Clear?
Yes.
Yes, sir.
Okay. Now, probability that good mileage means probability of good mileage and motorcycle X or probability of good mileage and motorcycle Y. Right? So can I write this one? Probability of X into probability of M given X?
Yes, sir.
Probability of Y into probability of M given Y?
Yes.
Okay. Now, see, similarly, you can do directly from here, means for understanding, means you have to find the good mileage, means motorcycle X is chosen into probability that good mileage X is already chosen, or Y motorcycle is chosen, probability of good mileage given that Y motorcycle, right? And you know, you have two motorcycle, then what will be the probability of choosing one motorcycle?
1/2.
1/2.
1/2. And this thing is given as, I think, 0.5
5
plus 1/2 into
0.7.
So it will be, I think,
0.6.
1.2 by 2, 0.6. Got it?
Yes.
Yes, sir.
Okay. 3 chocolates. Yeah, these questions are, I think, discussed. From a box containing 5 dark chocolates, 3 milk chocolates, 3 chocolates will be selected randomly without replacement. How many days can the chocolate be selected such that at least one dark chocolate is there? Okay, 5 dark chocolates, 3 milk chocolates. Okay, 1 second. See, there are 5 dark chocolate, okay? Right? And 3 milk chocolates, and you have to choose the 3 chocolates such that without replacement, at least one dark chocolate is there. Okay. Who has asked this question? After that, I will go. Yeah. See, in how many way? See, in total, I have 8 chocolate. Okay. Then, in how many way I can choose the 3 chocolates? 8C3. This is the total way. Okay. And in the question, it has asked about at least one dark chocolate should be there. If I minus from total way minus no dark chocolate, then I will get the at least one dark chocolate. Yes. Is it clear?
Yes.
Then what will be the no dark chocolates means? All the three should be milk chocolate. That means 3C3. Clear?
Yes, sir. Yes, fine.
Right? Or another way you can proceed, like at least one, say 5 are dark, 3 are milk. So you have to ask about at least one dark chocolate should be there. Then means 5C1 into 3C2. Okay? Or 5C2 into 3C1 or 5C3 into 3C0. Means at least one dark chocolate means dark chocolate can be 1, can be 2, can be 3. Okay. When you choose the one dark chocolate, then remaining 2 will be milk chocolates, 2 dark chocolates, then 1 milk chocolates, 3 dark chocolates, that means 0 dark chocolate. And both from both approaches you will get the same answer. Okay.
Okay,
Yes,
sir.
Okay,
Sir, I
so
think it's better to move to week 9 to 12 so that.
yeah. So you can ask the question from week 9 to 12. If you have any doubt in any question, so you can ask free. So feel free to ask from means I mean any question whatever you have. I think Divya has asked that question, exponential something, right?
Yes, sir.
Yeah, Divya. So what is your doubt? I mean, specific doubt of these things.
Sir, we had written that expectation of
See.
2 power n is equal to n by lambda into expectation. Yeah, that.
Okay, see. That things is not means you can say like you have.
Do we need that formula, sir? If it's not needed,
that
it's okay.
no. See, you can remember for the simplicity, but here this I mean this syllabus there is not much needed.
Okay.
But I will.
Then it's okay, sir. Then just leave it. Let's just go on the simpler doubts of other people. I don't want others to also get confused.
Okay. See, but let me these things. If you ask, then I can. Yeah, this formula is there, right? See, this is something for suppose in any question I ask, tell me expectation of x raised to power 4.
Yes.
Then you have to calculate this 4 and fx dx type of things. Okay. But if you put the as x raised to power 4, then you will get 4 by lambda exponential of x raised to power 3. Okay. And suppose exponential of x raised to power 3 is given, then you will get the correct answer. And it is simply for suppose exponential of x square. Okay. Then it will be 2 by lambda exponential of x. Sorry, expectation of x.
Yeah, which is 1 by lambda.
Which is 1 by.
Yeah. So
okay. It will be 2 by lambda square. It will be expectation of x square. Similarly, you know expectation of x is 1 by lambda.
Yeah.
If you put in this equation, this will be as 1 and it will be 1 by lambda, and you will get the variance of things directly. Okay.
Yeah, it was in regard to variance only that we had done this.
Yes.
Thank you.
Okay, so anything else? Anybody?
Sir, in mock test, same question in 16 questions that I'm unable to solve.
Which one?
16th question in mock test. Exponential probability.
Mock test, right? Where it's yeah. In timed or practice one?
In the same one. Yeah.
This question?
Yeah.
Okay. See. First, have you watched the lecture video of uniform and exponential?
No. It is last question and time was up.
If you know,
it's similar to graded assignment question.
First off, tell me, you know the concept of exponential or uniform?
Yeah, sir. Expectation is 1 by lambda,
and 1 minus e power minus lambda t. Is that f of?
Okay. See, in the question, duration of a video game is a random variable with an exponential distribution with mean 20 minutes. Means your mean is given, means 1 by lambda is given, right? And suppose that
Yes.
when you enter video arcade, two players are playing the game independently. Find the probability that exactly one of the two will be playing for less than 40. Okay. See, 1 by lambda is given to you. Okay. And two players are independently played. Suppose I'm saying there are two players X, A and B. Okay. And for A, they are taking as X random variable, and what is this? Yeah, probability that exactly one of the two will be playing less than 40 minutes. Okay. Then less than 40 minutes. Okay. You have to find these things, right?
Yes, sir.
Are you getting this point? You have to find
Yes,
the
sir,
probability that exactly one of the two will be playing for less than 40 minutes. See, both there are two players and both are playing independently. First, I will find the anyone for one of the player which will be playing for less than 40 minutes, and I will just add the for the second one. Okay. Then what will be this? You know what is f of x? That means probability x is less or equal to x for exponential distribution. 1 minus e raised to power minus lambda x. You
It
know
is
this.
coming 1 minus e power minus 2. F of x I
So
found it.
it will be 1 minus e raised to power minus lambda times this x, means 40. Okay. So your lambda will be 1 by 20. Right?
Yeah.
So this thing says for one player.
Okay.
Okay. I think I'm making some mistake.
So should we consider that one player is playing less than 40, another is playing greater than 40, and again change it into 2?
Oh, yes. That's why I'm saying I'm making some mistake.
This is the probability of playing less than 40 minutes for playing.
Yes, for this one. And for playing the greater than 40, it will be simply e raised to power minus lambda into 40.
Yes.
Means e raised to power minus 2.
Yes.
Yes.
Okay. That means, see, what will be this? Means first player is playing less than 40. Second will be play for greater than 40 minutes.
Yeah.
Yes, sir.
Okay. This is the one case. Means suppose
And
A
then
is
we
playing less than 40 minutes. That means these things, and B is playing more than 40 minutes. Okay. It is the first case. Second case can be B is playing less than 40 minutes and A is playing more than 40 minutes.
So we have to take two cases and then add them.
Yes.
So it will be 2 into e to
It
power
will be
minus 2.
2 times e raised to power minus 2, 1 minus e raised to power minus 2.
Yes, sir. Okay.
I think this is the correct one.
Here we.
Yeah. You are not audible. Hello.
Sir, why we found greater than 40, sir? That I didn't understand.
See, what is the question? You enter a video arcade. Okay. Two players are playing the game independently. Okay. You have to find that probability exactly one of the two will be playing for less than 40 minutes. Means suppose you have two players A or B, right?
So
Your voice is very low. Hello. Yeah, you can rejoin it. Your voice is-
Excuse me, sir.
Yeah, please.
Sir, in this particular question,
Mhm.
if we frame this in such a way that these two players are not playing independently, like they are playing opposite to each other in opposite teams, like dual fighting games.
Sir, hello, sir. Hello.
Yeah, please.
Yeah, actually, after
You are again not audible.
Sir, I
Hello.
was saying that
Yeah, please.
if players are not independent
Mhm.
of that playing time, can supposing a game where they have to play against each other, so if one wins, other will lose, and the
Then, yeah.
yes. And so how will the question differ if we have given the probability that A is playing against B and the chances of winning A is 0.6?
Can you repeat?
Sir, I just wanted to say that
Mhm.
these in this particular question number 16, the two players are playing independently.
Yes.
And how will the question differ if we have two players which are playing dependently on each other?
Then it will be conditional probability.
sir, hello.
Yeah, Nancy. You are again not audible. You are saying something.
Please write in chat.
Yeah, you can write in the chat. Yeah, Manan. Then suppose I'm saying it's dependent. Then it will be like it will be like conditioned. Okay. I am giving this condition like B has already played, then A is playing, or A has already played, then B is playing. That will be the something probability.
Okay, sir.
Okay, got it. According the question, objective of the question, your probability can be changed. Like if you are remembered in one question of week 12, there is question where binomial is used.
Oh, I don't know, sir, about week 12. I'm just.
Okay, so you can cover it. Okay, so anybody?
Sir, when you flip that inequality sign in that question number 16, you just minus it. It was 1 minus it e raised to. Just can you go to that page where you did that? The previous page, yeah.
Yeah.
When you just flip the sign from x greater than 40, then you just minus it. It was 1 minus e raised to the power minus 2. So you just minus 1 because it's just you're flipping it. Is it because of that?
See.
Can you explain it?
What is the meaning of this? I mean, what will be this? Right?
Yeah.
Okay. Suppose, can I write this one? E raised power minus lambda x equal to 1 minus probability x less or equal to x?
Yes, sir.
Okay. So can I write that e raised power minus lambda x? What will be this quantity?
Okay, opposite. Yeah,
X is
greater.
Okay. So probability of x greater than x will be e raised power minus lambda times. Clear?
Okay, yes, sir.
Initially it was probability x less than 40. Then I have applied this one, 1 minus e raised power minus lambda times 40, and probability x greater than 40 equal to e raised power minus lambda. Okay. These 4 to 5 formulas are you can remember. If you remember, then you will solve the exponential uniform questions in a quick way. Actually. Very easy way also. You must know the concept behind this, how it will come. This is the CDF. You will get this quantity by integrating the things. But for the simplicity, you can remember, and formula is not much tougher than. Okay, so you people will tell me. Suppose your x follows uniform A comma B. Then what is the PDF?
1 upon b minus.
1 upon b minus
b
a.
minus a, yeah.
Okay, x lies between a and b. Okay, and what will be the expectation?
X minus a plus b by 2.
Okay, and what will be the variance?
b square b minus a ka whole square by 12.
And what will be the CDF?
X minus a upon b minus.
All of you know these things?
Yes, sir. Yes, sir.
Okay,
Yes, sir.
this is the about uniform. And suppose x follows the exponential lambda with parameter lambda. So what is the PDF?
So
Lambda a function lambda e to power minus lambda x.
And lambda should be greater than 0, x
Greater
should
than
be
0.
greater or equal. Okay, what is the expectation for exponential?
1 upon lambda.
1 by lambda.
And what is the variance?
1 upon
1
lambda
by
square.
lambda square.
And what is the CDF?
1 minus
e
1
raised to power
minus
minus
e to
lambda.
power minus lambda x.
And suppose I'm asking probability x greater than x, it will be
lambda e to power minus.
That's all
lambda minus.
about exponential and uniform distribution. This formula is only used for solving the question. Just read the questions carefully, whatever you have given and what you have to find. That's it.
Hello, sir.
Yeah.
Could we also do for hypergeometric the expectation and variance? For
Hypergeometric variance is a complicated one. Okay.
Yes, sir.
For mean, you can remember, I think formula is m into n by 2.
Sorry?
You know,
mn by
2. Sorry, mn by capital N. Okay. Suppose whatever you have capital N ball, okay, in total, out of which you have m red ball. Okay. And suppose n minus m ball will be I'm taking as yellow. Yes. Okay, and I'm choosing the sample of n size. Okay, sample of n ball without replacement. Twist, you can twist, or you can say important point of hypergeometric is without replacement. Okay, you are drawing n balls from this capital N balls, okay, without replacement. And suppose x is something which represents the number of red ball, okay. Then what will be the probability of x equal to I? I is something means it can be 0 red ball, 1 red ball, up to no. Yes. Okay. So what will be the probability of x equal to I?
n into small m into small n upon capital N.
No. You are
in terms of combination.
No. You are taking. No.
Yeah,
I'm asking about the probability and
probability.
You are
yeah, it would be.
me
Sorry. It would be m c x.
No, not x. I. See.
Yeah.
What is I? What is x? X is representing the number of red balls. And see, first of tell me what's total sample space.
That would be n, capital N, C,
n,
small n.
Is it clear? Means out of those capital N balls, you are choosing the small n balls. This is hypergeometric things is simple probability. Now, this x is represented the number of red ball, okay, and in total you have m red ball. So out of m red ball, I red ball you are choosing. That means MCI, okay, and the remaining, see, you in total you are choosing the small n ball.
Yeah.
Okay. So from remaining ball, you will choose n minus I. That is the something hypergeometric distribution.
This is probability.
This is the probability, not expectation. If I'm asking about the expectation, then you have to calculate like this one. Means probability of 0 into x equal to I plus 1 into probability of x equal to 1 plus 2 into probability of x equal to 2 and so on. m red ball is there. So m into probability of x equal to m is there. So when you calculate these things, you will get m into n by capital N.
Okay.
Okay.
So there was a formula we were doing, I don't know, n into n minus 1 by 2 or 6 something, and then something by 12, I don't know, n into 2 and...
See, that is something.
That was,
if you n natural numbers, okay?
Yeah.
Then suppose I'm asking about the sum of these n natural numbers, so it will be n into n plus 1 by 2.
Sir, can you go to previous slide, please, for a second?
This
Okay,
one?
sir. Yes, sir. I've done so.
Is
Sir,
it
you
clear?
can yes, sir. Now we can move. I just wanted to know the expectation formula. I was noting down. Thanks.
So there was, I think, a mean and a variance of another distribution that I think I've forgotten. It was something like this only.
That is the, you are talking about the discrete uniform distribution.
Yeah, that one. Could we discuss the expectation variance?
See, what is the discrete uniform? Your random variable is taking
Instead
value n, and discrete uniform distribution means probability is uniform. It's same for all things.
Oh, okay.
As in continuous uniform distribution, PDF is 1 upon b minus a. Means suppose your region is this a and this b is this. Okay, this thing.
Yes.
Means probability is same. Okay, that is the something. Means that is
Okay,
the
that was discrete. That was continuous uniform distribution, and this is discrete uniform distribution.
Yes, discrete means suppose your a is there, okay, and b is there, okay, and it's k. Means k is the something probability, means it will be same for this point to this point.
Yes.
Okay.
Yes.
Then what will be the expectation? Means summation of x into px.
Yes.
Yes, sir.
Okay. Then what will be some means 1 into 1 by n plus 2 into 1 by n plus 3 into 1 by n and so on, n into 1 by n.
Okay. Yeah.
And
so
here 1 by n will be common, then 1 plus 2 plus 3 plus so on plus n, right? Then 1 by n, and this is the sum of n natural number, so it will be n into n plus 1 divided by 2. This n will be cancelled out, you will get the n plus 1 by 2.
Sir, could you show the previous slide just for a second? So it's x is 1. Okay. Why does it only take 1? It doesn't take 0 value?
No.
It will never take 0 value.
This is the property of discrete uniform.
X has to be greater than 0.
Yes, it will be x as if your x is taking value like 1, 2, so on, n. Like suppose you roll a die, okay?
Yes.
Then you can get the value 1, 2, 3, 4, 5, 6.
Yes.
Okay. What with the probability of getting 1?
1 by 6.
1 by 6.
1 by 6 for getting 2.
Okay.
1 by 6 for getting 3. 1 by 6. Okay.
Yes. Okay.
And suppose for that I'm saying find the expectation, then you will directly calculate the 6 plus 1 by 2, that is 3.5.
Okay. So this is expectation. What about variance, sir?
Yeah, for variance, you can calculate expectation of x square.
Yeah, I think so.
It will be 1 square into 1 by n plus 2 square into 1 by n plus so on plus n square into 1 by n, right? Then it will be 1 by n common, 1 square plus 2 square plus so on plus n square, right? And this quantity you have to remember, sum of the square of n natural number is n into n plus 1 into 2n plus 1 divided by 6. This is the sum of this, and will be cancelled out. You will get the n plus 1 into 2n plus 1 divided by 6. This is expectation of x square, and expectation of x is n plus 1 by 2. And for variance, expectation of x square minus expectation of x raised to the whole square. So square this quantity, you will get the square of variance of the discrete uniform distribution. Okay.
Okay. Yes. Thank you so much, sir.
Sir, sum
Sir,
of
one more thing is
sum of 1 square plus
also
2 square dot dot n square is equal to
1 by 1 by.
Yeah,
Yeah, please.
a
1 by.
upon 1 minus 10.
Sorry.
Sum of 1 square plus 2 square dot 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 n square is equal to a upon 1 minus n.
No. It's sum of n natural number square of this. This is this. N into n plus 1 into 2n plus 1 divided by 6. So if you go with the 10, in place of 10, it will be 10 into 10 plus 1 into 2 into 10 plus 1 divided by 6. Okay?
Okay. तो सर किस नेचुरल नंबर का सम a upon 1 minus n
No, that is the something geometric series. Suppose you have a and ar plus ar square kind of things. Okay, then that is something a upon 1 minus r.
Okay. Thank you.
First term divided by 1 minus r. Okay, when r is less than 1.
Thank you, sir. क्योंकि रोलिंग डाई वाले क्वेश्चन में सर ये फार्मूला यूज हुआ था. Sum of मतलब रोलिंग डाई. Thank you, sir.
And okay. Ayush has asked question activity 12.2 question 9. Ayush, are you there?
Yes, sir.
Okay, 12.2. This question, right?
Yes, sir. 9th question.
Okay, x is uniformly distributed between 0 and 10, then find the probability x plus 10 by x. 0 to 10. So see, it is given that x is between 0 to 10, right? And you have to find the probability x plus 10 by x greater or equal to 7, right? So can I write this one? X square plus 10 whole divided by x greater or equal to 7?
Yes, sir.
Just multiplied by this. Okay?
Yes, sir.
So can I write x square plus 10 greater or equal to 7 times x?
Yes, sir.
Okay. Now, can I write this x square minus 7 times x plus 10 greater or equal to 0? This quantity,
yes,
okay? Now, just factorize this. Okay? Can I write this one?
Yes, sir.
That to x square minus 2x minus 5x plus 10 greater or equal to 0 is there. So probability x can take as common. It will be x minus 2 minus 5. X minus 2 is greater or equal to 0, right? So it will be x minus 2, x minus 5 greater or equal to 0. 6. Now, your uniform distribution is from 0 to 10, right?
Yes, sir.
And 2 is here, suppose 5 is here, for example. See, you have to find the values of x for which this both quantity will be, after multiplication, this quantity will be greater or equal to 0, right?
Yes, sir.
So tell me, if I'm taking the value less than 2, means suppose as 1, then it will give you, it will be
positive,
minus
sir.
1 and minus 4, and multiplication of this will be greater or equal to 0.
Yes, sir.
Okay, means if your x is less than 2, then quantity will be greater or equal to 0.
Yes, sir.
Right? Now, for this quantity, if you go 2 to 5, means suppose I'm taking as 4. So it will give you negative, means 4 minus 2 into 4 minus 5. So 4 minus 2 into 2 into 4 minus 5 is minus 1, and 2 minus 1 will give you negative. That means this condition is not satisfied, right?
Yes, sir.
Now, if your x is greater than 5, okay, means suppose 6, that means
6 minus 2 is 4 into 6 minus 5 is 1. It will give you a positive quantity.
Yes, sir.
Means if x is greater than 5, then it will give this positive quantity.
Yes, sir.
Till this point is clear. Now, what is this? Can I write this one? Probability x is greater or equal to 2 or probability x is greater or equal to 5?
Yes, sir.
Because for these two quantity, I'm getting this condition is satisfied, right? Now,
yes, sir.
Probability x is less. Can you tell me what is the probability of x less or equal to x for uniform distribution? X
The
minus
x minus a upon b minus a.
Okay, and here your x is follow uniform 0, 10. So it will be 2 minus 0 divided by 10 minus 0.
Yes, sir.
Plus, can I write this as 1 minus probability x is less or equal to 5?
Yes, sir.
So next quantity will be 2 by 10 plus 1 minus probability x less or equal to 5. So can you tell me what will be this things?
5 minus 0 upon 10 minus 0.
Okay, it will be 2 by 10 plus it will be 1 minus 5 by 10 means 2 by 10 plus 5 by 10,
5 by
that
10.
is 7 by 10, 0 points. I think this is the correct one.
Okay, sir. Thank you, sir.
Got it?
Yes, sir. Yes.
Okay.
Sir, can you go to the previous
Can
page?
you go to question number 4 and exercise 12.4?
The previous one.
This one?
Okay. Yeah, okay, sir. It's okay.
Okay, someone has asked 12.4. Which question?
Question number 4, sir. So actually, I had to ask question number 1, but I think it will be covered in question number 4. In exercise 12.4. Yes, sir, this one. Yes, sir, this one.
12.3, question number 6. I got 0.4. What is this? One second. 12.3.
Okay, sir.
1 second. After that, I will come to. What is the probability that delay in arrival is less than 15 minutes? Yeah, I think who is this? Arun Rajan, are you there? Hello.
Sir, yes, sir, 6th and 7th, sir, can you please explain this?
Just 6 and 7.
Yes, sir. Yes, sir.
Okay, first let me complete the Manan doubts. After that, I will cover the both questions. Okay.
Okay, sir.
Okay. Manan, see, in this question, what is the value of variance of x? See, in the question, it is given that it is follow an exponential distribution, right? So
Yes,
just
sir.
tell me what is this? Fx is k into e raised to power minus 5 times x, and x is greater or equal to 0, right?
Yes, sir.
And you have to find, see, for finding the variance of x is what? Is 1 by lambda square.
Yes, sir.
Okay, but before finding the variance of x, you have to find this quantity.
Yes, sir, value of k.
How you can find? Just integrate
0 to infinity. Okay, sir.
Okay, e raised to power minus 5 dx range should be 1. In PMF, you know, sum of the probabilities should be equal to 1.
Yes, sir.
And
Yes,
in
sir.
PDF, area under the PDF should be 1.
Yes, sir, sir, because it's integrating to infinity.
See, why integrate? Because this one, x is greater or equal to 0 means lower limit of x is 0 and upper limit will be infinity. Okay, so from here, I can k into, I can write it as e raised to power minus 5x divided by minus 5. If you know the integration.
Yes, sir.
Okay, so can I write this one minus, sorry, k by 5 Okay, minus k upon 5 e raised to power minus infinity minus e raised to power 0.
Yes, sir.
And you know e raised to power infinity is what? Is what?
Is
0.
sir.
0 and it will be 1.
1.
Okay, so it will
K
give
by
the
5.
k by 5 equal to 1. That means k is 5. Okay,
sir.
and for the simplicity you can directly interpret k as 5 because these things are always same.
Yeah, if you apply the formula, PDF formula,
Because for exponential PDF formula, lambda into e raised to power minus lambda is x is there. Okay, and here you are given k into e raised to power minus 5x. Okay, hello.
Yes, sir. Yeah.
Yeah. Then
yes,
these
sir, I
things
got
and these things and these things is same. That means
Yes, sir.
from here you can interpret k is as 5.
Yes, sir, I got it now. I got it.
Then variance will be 1 by lambda square and your parameter is 5, so 1 by 25. Right?
Okay, sir.
Okay, now activity 12.3.
And excuse me, sir, even if we hadn't got that particular answer, we can use e to power minus 5x, and 5 should be equals to lambda. So we can simply write this 1 by, if we have already given 5, so we will take 1 by lambda square, that will be 1 by 25.
That's it.
Okay, sir, thank you.
Okay, so someone has asked, I think activity
Yes, sir.
12.
Yes, sir. This one, the area, it is because you've given the explanation in the discussion forum for the area, which is the trapezium formula we used. The peak of the probability is the height.
Okay, see, what is a peak? Can you tell me what is this area? What is the name of this area?
Trapezium, sir.
Trapezium. Okay, just tell me this region 10, 18. Okay. Yeah, 1 second. Yeah, hello.
Yes, sir.
Hello, I'm audible.
Yes, sir.
Yes, sir.
Yeah, yeah. One more thing. See, in the stats 1 syllabus, integration is not there. Okay, means you do not need to do the integration at all. Okay, I told this one just for you know how you can calculate. Okay.
Yes.
And first thing, second thing, I think Divya has asked that discrete uniform, right?
Yes.
And Divya, just remember things. It will be true. This expectation value will be true only when your variable is taking value 1, 2, 3 up to n.
Yeah, so it's
So not at all like you suppose question is like 0, 2,
yeah,
4, then you cannot apply the discrete uniform.
it has
Okay?
to be natural numbers, taking natural numbers.
Kind of.
That I.
You can say sequence will be like 1, 1, 2, 3, so on, and for each one probability will be same.
Okay.
Okay, it's 1 by n.
That is the discrete random variable
That
is
discrete
taking
uniform
values only equal same as natural numbers.
Sorry.
Can we say that the discrete random variable is taking only values equal to the natural numbers?
You can say kind of.
Okay.
Sequence will be similar. Like it can be like 2, 3, 4, 5. 1.
We
Suppose I
take
1, 2, 3,
yeah,
4,
we have
5.
to take 1, 2, 3, 4, 5.
Yes,
Yeah.
suppose for example dice 1. So it will be 1, 2, 3, 4, 5, 6. Okay.
6,
and
yes.
for each probability is 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6. Okay.
Yes,
then it's
sir.
a discrete uniform. Then you can apply the formula. Otherwise, suppose sequence is like 1, 3, 5, and 7, but probability is same for each one. Then you cannot apply the discrete uniform because
yes, because that formula does not apply. Yeah.
okay. And just see these things I have told you because integration, how you can calculate this concept
It's the
behind
derivation of that formula.
yes, but integration is not will not come
required.
Yours. Yes. Okay, got it, Mana?
Sir, in this page you are there, graded assignment 9. I have a lot of doubts, sir. This fifth question which is seen.
Graded assignment 9.
Yeah, this one which is seen on the screen, a biased coin with probability of heads.
Biased coin. Oh, see, first let me complete
Yes.
this one.
Yes,
Okay,
yes, sir.
this
Yes, sir.
trapezium. Oh, okay. See, you have given this area. Okay, this things. Fx is given. Okay, and it's 6, 10, 80. Okay. This is the 10. This is the 80. Okay, and this is the 12, 14, 16. So 12, 14, and 16, and 6. This is x minute. Okay, see, you know the peak. See, suppose this is A. Okay, this region, and this whole region is as B. Okay. Hello.
Yes, sir. Yes, sir.
Yes, sir.
And this is the height h. Okay, and you know area of trapezium is what?
Half into the parallel, sum of the parallel sides.
Into h. Okay, and you know area is always equal to 1. Should be?
Yes, sir.
Yes, sir.
Okay, then you know what is your A will be there here. Miss?
Is 2.
4.
A is 4. Okay, because difference between 12 and 16 is 4 and B is 8.
8.
Right? Into h equal to 1. And from here you can get 12 by 2 into h equal to 1. That means 6 times h equal to 1. That means h equal to 1 by 6.
Yes, sir.
Right? You get the peak one. Right? Hello?
Yes, sir.
It's
Yes,
clear?
sir. Yes,
now,
sir.
Now, next question is, probability that delay in train arrival is less than 15 minutes. Okay. So, for less than 15 minutes, what will be this? Means you have to calculate this before this quantity. Okay. Suppose 15 is there. Right? So, what will be A for 15?
3.
Okay. You have to find only from this 10 to this region, right?
Yeah.
This green things. Right? So,
Yes.
it will be 3. A will be 12, say 15. Right? And what will be B?
5.
By 2 into, you know, height 1
by
by. This is the correct answer. It will be 8 by 2. It will be 8 by 2, 4 by 6. That means 2 by 3. Right?
Sir, but how we took 3, sir?
No, see, what is A? Initially, A is 12 to 16.
Yes.
Now you have to find the area train miss before 15.
Okay.
Okay, so you have to consider from this point to this point.
Yes, that I got it.
Your new trapezium is this one. Okay, and 12 is this, 15 is this for A. Okay.
This 15 part I could, I mean, taking 5 I could understand, but the upper part, how we can take it just as -1, 4 minus 1.
No, it's 12.
12,
Initially,
okay.
A
This
is 12
okay,
and this 15.
okay, okay, sir.
And for the previous one, A is 12 and this 16 was there.
Okay, sir, got it.
Got it?
Yes, sir, yes, sir.
And the next question is what is the probability that train arrival will be more than 11 minutes but less than 14 minutes? Okay. Let me draw here. X f of x. So 10 was there and I think it was 18, right?
Yes, sir.
Yeah, 12, 16, right?
Yes.
So see, now you have to find probability more than 11 minutes but less than 14 minutes. Okay, that means these things, right? Okay, suppose your 11 is here, something here. Okay,
Okay.
and more than 11 and less than 14. And so if it is 18, then middle point will be 14.
Yes.
Right? Now, you have to find from this things to this thing.
Yes, sir.
More than 11 minutes and less than 14 minutes. So can I put for 12?
Yes.
Okay. So I will have this region as first and this region as the second.
Correct.
Okay. And for the first region, how I can calculate the area?
It will be a rectangle. We can take 2 into 1 by 6.
Area of first region is 2 into 1 by 6. Okay,
Yeah.
that is 1 by 3.
Yes.
Why 2? Because this is breadth and length is height is 1 by 6. Okay.
Yes.
Okay. And you have to find this region of the second, I mean area of the second region. Okay. So can you tell me what is this one? This is something 12 point, 12 comma 1 by 6. This point.
Yes, sir. Yes.
Okay. Now, this you have to find this point. Then you will get this trapezium, this thing, this red one. Okay, this is the another trapezium. If you see, are you getting?
Yes.
Okay, so now you have to find this point. Okay.
Okay.
Then how you can find this by the equation of line?
Yes, sir. Midpoint.
Midpoint. So equation of line is equation of line is y minus y1 divided by x minus x1 equal to y2 minus y1 divided by x2 minus x1. Okay. Now, what is your x1 y1? This is 10 comma 0. Okay. And this point is, what is this? This is 10 comma 0, right?
Yes.
So direct apply midpoint.
Okay.
So
and this is 12
know
comma
this
6.
is the
Okay.
midpoint, but how we know this is the midpoint?
Because see, you have to calculate this region, this one, this red thing.
No, sir. I got as we have to calculate this particular y coordinate. We know that the x is 11, so we can find the equation and put x equals to 11 and find the value of y. But that particular person said that it is the midpoint. So how we know that this is the
midpoint of these 2 points?
Yes. So how we know that this particular point is midpoint of 12?
11, 1 by 12.
Okay, so just apply this equation of line. You know this formula in 10th or 11th class.
Yes, sir.
Okay, equation of line. So for these 2 points, your y1 is 0. See, this is y1, this is x1, and this will be x2 comma y2, right? For this point,
सर हम तो डायरेक्ट मतलब मिड पॉइंट का भी फार्मूला अप्लाई कर सकते हैं.
Yeah, you can apply it. Okay, but suppose someone is not know that formula. Okay, so y1 is 0 divided by x minus x1 is 10. Okay, and y2 is what? Y2 is anybody? This 1 by 6, and y1 is 0, and x2 is 12 minus 10, right? Now you will get y by x equal to 1 by 12, right? No, it's x minus 10. It's x minus 10. Okay. Now, can I write it? 12y equal to x minus 10.
Yes, sir.
So 12y equal to C. For this region, for this point, I have to find the y coordinate. Okay, and x coordinate is 11, right?
Okay, sir.
X is 11 here, you know, and I have to find the y1. So just put the x as 11. 11 minus 10. It will be 12y equal to 1. So you will get the y as 1 by 12, right? So you got this point. Okay. This was 10 comma 0. This was 12 comma 1 by 6. This is 11 comma 1 by 12, right?
Okay.
Manan, 11 is a midpoint of 10 and 12. That's the reason this is a midpoint between the 2 points.
You can direct.
Actually, my confusion, because I can apply the midpoint, but how come this line have a midpoint where 11?
If you see, if you got the confusion whether it will be midpoint or not, so just apply simple the equation of line. That's it.
Yes, sir. Yes.
Okay. Suppose instead of 11, it was something. Suppose it is 11, and instead of 12, it was 13. Okay. Then you will get 11 minus 10. Here it will be 13 something. I mean, accordingly, value will be changed. Right. Now, what is this? This is reverse of the trapezium.
Yes.
Okay.
These two are parallel.
So in this region, I mean, reverse of the trapezium, can you tell me what is the height?
1 by 6.
No.
Height is 1.
Height is just 1.
The height is 1 because we are 12 minus 11, it will be 1.
No, not 12 minus 11. See, it is the reverse of the trapezium. It is just something like that. Okay. 11, 12, 12 comma 1 by 6.
ऐसा नहीं कर सकते क्या कि बड़े ट्रायंगल में से छोटा ट्रायंगल घटा दें सर?
It will be no. This is not a triangle.
No, sir. The bigger triangle minus the smaller triangle will give us the area of 2, right? I mean, I just did it that way, but not sure if the answer was right.
Okay. So, can you tell me this is clear or not? First, tell me this.
Yes, sir.
This is 11, 12, 11, 12, and corresponding 12, it is 12 comma 1 by 6, and corresponding 11, it is 11 comma 1 by 12. Right?
Yes,
This is the trapezium. And you know, the area of trapezium is A means difference between these two. So what is difference between these two?
1.
So
1 by 6.
1 by 6 and the lower one is 1 by 12.
1 by 12. This is A plus B. Okay. Into 1 by 2 and H is 1.
Yes, sir.
Okay. Now it will be 1 by 2. It will be 12 plus 6, 18. Yeah, it will be 1 by 4. It will be 1 by 8. So area of the second region is 1 by 4. Now you have to add these two. Means 1 by 4 plus 1 by 3 will be the correct. No, it's not 1 by 1 by 8. 1 by 8.
1 by 8.
This is the correct answer.
Okay, sir.
Got it?
Yes, sir. Thank you, sir. Thank you.
So,
sir, in discrete uniform distribution, sir, do we have a CDF, a cumulative distribution for that?
Okay. CDF things is not in your syllabus for discrete.
Okay.
Sorry, sir, what did you say?
See, CDF. So, can you tell me? One second. What is the CDF actually? Suppose I'm asking about the probability x is less or equal to 3 for discrete uniform. Okay. So you can calculate, but direct formula is not there. Is it clear, Abhikant? Suppose discrete uniform is 1, 2, 3, 4, 5 up to n is there, right? And for each one you have probability 1 by n. Okay. And suppose I'm asking that you have to find the probability x is less or equal to up to 4. Then how you can calculate? Just adding the probability.
Yeah.
Right?
Yes,
then what is this? This will be 4 by n. No direct formula is there, but you can calculate these things also. Right?
Okay. Yes, sir.
Don't go with the like, yeah, this formula is there and you have to just formula. Yeah, knowing the formula is good, but concept must be clear behind that formula for discrete or continuous, whatever. Just for example, in exponential uniform, you know the CDF of the uniform x minus a divided by b minus a, but you must know how this will come. This come for the by the integration of things. Okay, but for this foundation level, you have to just know the formula. Okay.
Yes, sir.
Okay, so anybody, any doubt? So
I have a doubt in practice mock.
Mock practice, right?
Yes, sir.
Which question?
Question number 7.
Have you go through the solution
I
PDF?
have doubt in option number 4.
Okay. Have you gone through the solution PDF or not?
Yes, sir, but I'm not getting.
Okay. Let me write there. One second. See this quantity, probability of A complement union B union C. Probability of A complement union B union C is equal to 1 minus PA. 1 PA plus PA plus B. Minus. See, you can do it Venn diagram also.
Okay.
Okay. See, so should I go through the Venn diagram or formula one where you heard out?
Formula.
See. But in that formula one, if you do with the Venn diagram, that will see. Can I go with like that? Just take it as one event. Okay.
Okay.
Probability of A complement union B union C. I'm taking as D, for example. So I know the formula of A union B.
Probability A complement plus probability
It is
A
intersection.
minus A complement intersection B.
It is intersection. No, it's okay. So A complement intersection D. Okay. So instead of D, can I write again means B union C?
Yes.
Now clear?
Yes.
Now, see, there is a these things you have to consider. Means in the question, if you see probability of A complement intersection B union C as written as probability of B union C one second, minus probability of A intersection B, okay,
Yes.
minus probability of A intersection B minus A intersection B. Yeah, see,
So I'm not getting this line.
one second. This is something where you can understand by the Venn diagram in an easy way. See, A complement intersection B union C. Okay, so suppose this is your whole sample space. Okay, and A is there, B is there, and C is there. Okay, so can you tell me what will be the A complement? The whole region except A.
Yes.
Okay.
Yes, sir.
That is the A complement. Now, A complement is this blue region. Now, you have to find intersection with B union C, right? So, what is the B union C?
B union C. This region here, see, green.
This
Yes.
green region is the B union C.
Yes.
Right? Now, what is the complement between these two? This red region? Okay. Probability that A complement intersection B union C. Okay. That means A complement is this whole blue region except A. Means this except A, this black one except this black one. Your whole things is A complement, right?
Yes.
And B union C was green region, means including this intersection part. This part is also included, right? In B union C. Okay. And what is the common region between A complement and B union C? This red region. Are you getting or not? Hello?
Yes, sir, I'm getting.
Getting? Then just tell me, how can I write? How can I write this red region? Probability of B union C. Okay. Hello. Hello. Am I audible?
Yes, sir.
Yes, sir.
Okay. So can I write probability of B union C minus of, if you see, I have to find only red region, but this green region is also included. Means A intersection B is also included. So I have to subtract. Okay. Are you getting? This
Yes,
A
sir.
intersection
Yes.
B and this A intersection C. Because see, this is A, this is B, this is C, right? So B union C is this red region which have lined. Okay. Now you have to find now our new region which have to calculate this one. Common region is this green one here. Okay. So for this green one, whole B union C, I have to minus A intersection B and A intersection C. This region and this region. Are you getting?
Yes.
And we have to add probability of A intersection B intersection C because we are subtracting 2 times. This see, this is your A, this is your B, and this is your C. Okay, when you subtracting A intersection B, then you are subtracting this region. Okay, when you are subtracting A intersection C, then you are subtracting this region.
Yes.
If you clearly was this region, we are subtracting 2 times. But this region is also included in B union C. So you are subtracting 2 times. So 1 time you will have to add.
Okay, sir.
Got it or not?
Yes, sir. I'm getting. Sir, if I want to evaluate without Venn diagram,
then it will be difficult. See, just simply draw the Venn diagram. You will get the clear vision.
okay, sir.
Okay.
Yeah.
This
So
point
that
is clear?
means we should instead of memorizing formulas, use Venn diagram.
Yeah, Venn diagram, using Venn diagram is much better because suppose you forgot the formula. Venn diagram will give you clear vision.
Yes, sir.
Got it? This one
Yes,
clear?
sir. Yes.
Just now, just put this formula in the place of this one and add and subtract. You will get it.
Yes.
Okay. See, suppose instead of I'm putting this quantity as this here, then this will be minus. So this quantity will be cancelled out. And this quantity will be minus plus, and it will be minus. Then you will get this quantity direct is 1 minus probability of A, because probability of A complement I can write is 1 minus PA, right? And this quantity probability of A intersection B plus probability of A intersection C minus A, B, C. This one is clear?
Yes, sir. Clear.
Okay.
Thank you, sir.
So anybody else? Any doubt?
Yes, sir. Rated in assignment 9, sir.
Week 9.
Yes, sir. Yes, sir.
Which question?
2 and 3, sir. This takes us from, yeah.
Okay. Oh. Yeah. Okay. Have you gone through the solution PDF? I mean, do you understand with the solution
No,
PDF?
I went through the solutions, sir, but I couldn't understand. That's why I'm asking you.
Okay, okay. Let me open that, then it will be easy to. Week 9, okay. See. In an organization, Texas, a lucky draw this month, and 1,000 tickets are sold for $M each, right? So can you tell me what is the net gain? Net gain means profit plus loss, profit minus loss.
That is the sales he is making. He's selling it for $8. I mean $M.
Mm-hmm.
Then the equal that is after giving the winning, what is the profit he's making? Equal chance of winning.
Yes. Each has an equal chance of winning, and yes. How many tickets has been sold? Each has an equal chance of winning. Okay. In the question, it said the X tickets will win $8. Okay. And Y tickets will win $B and Z tickets will win $C. right?
Yes.
And
Yes.
what is your X? X denote the net gain from purchase of one ticket. Okay. And your one and 1,000 tickets are sold for $M each. Means one ticket is sold by $1. Sorry, $M.
Yes, sir.
Then can you tell me what will be the net gain? Suppose I'm saying you are in loss.
Okay.
Then
That will be less than the $M. I would
minus
have
M.
sold it. Yeah, minus M. Okay.
Minus M. And suppose X ticket will win $8. Okay, X tickets will win $8. That means it will be A minus M.
Okay.
$8 X tickets. See, X tickets will win $8. That means rest of the he lost. Are you getting? Net gain means for X tickets it is $8 winning.
Okay.
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 And for loss what will be?
Minus M.
Minus M. Similarly for Y ticket. Similarly for Z ticket.
Okay. So for each one we find the loss. Okay.
Yeah, because what is your X is here? X denote the net gain, not profit.
Okay. Okay.
Okay. Similarly, what is the at the last you have to find the probability of X takes the value less than P. That means less than P. Similarly, you can calculate. And for example, you can see suppose you purchase 5 tickets of $1 each. Okay.
Okay. Okay.
Okay. Out of which $1 will it was sold for, it will win 1,000. Okay. And 2 tickets will win 5,000 and 10 tickets will win $100. $100. Okay. See, what is X? X is one ticket will win $1,000. Okay. And 2 tickets will win $500 and 10 tickets will win $100. Right?
Okay, sir.
Then it what is the probability that X less than the $500? Means 499, 99 and minus 1.
Okay.
Suppose you purchase one ticket. Okay. You purchase one ticket of $1. Okay.
Okay. Okay, sir.
And for loss at that ticket will be minus 1.
Okay.
And for X tickets which is sold for $1,000.
Okay.
Okay. But see, in this question we have to consider only less than 500.
Less than 500. Okay.
So consider with B. Okay. Suppose for B, you can you take what is B? B is the something 500. Means you purchase 2 tickets for $500 each.
Okay, that is 1,000.
That is 1,000. But
okay,
X is the net gain, so net gain will be 499.
Okay.
Means how many how loss you will have for one ticket? Minus 1.
Okay.
But for Y tickets, I mean, but for these 2 tickets, you have $500. So if you lost $1, then you will have 499.
Okay.
Are you getting? Net
Yes,
gain
sir.
means your 499 will be profit and $1 will be loss.
Loss. Okay. Okay. Got
And
it.
similarly for the C, just add the probability.
Okay,
Got
sir.
it?
Okay. Okay.
And
the next one also, sir. You say in a group of N people, X are photographers.
N minus R.
Yeah.
Yes.
How they got? I saw the answer is M+1.
See, Y is the random variable which represents the number of photographers. Okay. So it can possible no, there is 0 photographers, means there is journalist.
Okay.
Okay. Suppose you have 10 photographers and 5 journalists.
Journalists. Okay. Okay.
And I'm saying you have to choose the 6 people at random.
Okay.
Then what value X Y will take? 0 to 6. It can be 0 photographers, 1 photographers, 2 photographers, 3 photographers, or all 6 are photographers.
So if I say there are 10 photographers, and we have to choose which represents the number of how many possible. So the next number we have to take. I mean, the next possibility.
No, next number. So just count 1 to m is m.
Okay.
And g plus 0 means plus 1. You have to count. Suppose 0 to 6. How many number will be 0 to 6? 1 to 6 is 6.
Okay.
In counting, and 0 means 7.
I couldn't understand the logic.
One second. Where is my Jamboard? See, I told you the 6th one. Okay, 0, 1, 2, 3, 4, 5, 6. Okay.
Okay.
So how many is there? 1, 2, 3, 4, 5, 6, 7.
Okay. Okay.
It is asking about how many possible values. So it will take 7 values in which it includes 0
the
to
0
6.
also. Yeah, I didn't include the 0. So.
Okay.
10.6 activity question 3, sir.
10.6.
6. Yeah.
Okay.
Activity question 3.
Okay, x, y, z, and y is equal to 2x. See, variance of x equal to 2 and variance of z is 7 standard deviation. See, you have to find the standard deviation of x plus y plus z. Okay, so first of all, find the variance of x plus y plus z. In the question, it is given that y equal to 2x. So variance will be x plus 2x plus z. Okay, so it will be variance of 3x plus z. And in the question, yeah, it is given that x and z are independent. So I can write 9 times of variance of x plus variance of z. This things is clear?
Yes, sir. Yes, sir.
Okay, so it will be 9 into 2 plus 7. That's it.
This 2 part only I had a doubt. That is the variance of the x, which is already given. We have to take. Okay, sir. Got it.
Okay, and this is variance and standard deviation. You have to take the square root.
5.
Okay, and the 5 is the correct answer, right?
Yes, sir.
Okay, so anybody, anything else?
Sir, one more.
Yeah, please. Sorry?
11.4, 11th week. 11.4, that question 4.
11.4.
Yes, sir.
11.4 question. What is the probability that translated message is wrong, assuming that message is wrong when there is at least one bit error? See, what is the, from here you can find this CDF, PMF. Okay. See, hello.
Yes, sir.
Okay. So X is what? X is what number of bits that change. Okay.
Okay.
And in this question, it has asked what is the probability that translated message is wrong. And when translated message is wrong, when message is wrong, when there is at least one bit error, means you have to calculate probability X greater or equal to 1.
Okay.
Means 1 minus probability X equal to 0. And just apply the PMF. Means it said message is wrong when there is at least one bit error. Okay. So can I write it? 1 minus probability X is less than 1?
Less than 1, yeah. Then
1 minus probability X equal to 0?
0.
Just apply the PMF for this.
Okay, sir. Okay. Got it.
Got it? Anybody, anything else? You can ask, otherwise.
Sir, this formula you have given for uniform and exponential. So what are the other expectation and variance for other discrete also we have like that, sir?
Yeah, you can take it from video also.
Okay, okay, sir.
Okay, so anything else, everybody? So you can ask, otherwise if you don't have any doubts, we can close. Anything else? Okay, so I think we should close, right?
Thank you so much, sir. You've
Okay.
had such beautiful sessions and you have so
Okay.
much patience. You solve the question completely till we understand it.
Okay.
Thank you so much.
Yeah,
It's been
thank
really
you.
helpful.
Yes, sir.
Thank you.
Thank you very much.
Thank you. So bye everyone and all the best. Very best for tomorrow exam.
Thank you, sir. Thank you, sir.
Okay, so just revise your things very carefully and do. And you can ask on forum also. Okay.
Thank you so much, sir.
Thank you. Bye bye. Bye bye.
Thank you, sir.
Sir, do you have, can you connect in LinkedIn?
So what?
Sir, LinkedIn is because it's
Yeah,
a last class.
I'm on LinkedIn.
So can you share?
You can search it on my name.
Okay, sir. Okay, fine. Thank you.
Okay.
Sir,
Thank you.
what will stats to cover? Which topics?
Actually, I'm not aware of stats 2. Actually, you can.
So you will not be teaching stats 2?
No. I'm in stats 1.
Okay.
And stats 2 top. You are in stats 1, right? No.
Yes, sir. I just wanted to know what will happen. in
Okay,
stats 2.
stage 2 is about like hypothesis testing, normal distribution, Chebyshev inequality kind of things.
Sorry,
There is
hypothesis testing and?
normal distribution, Chebyshev inequality, inference, Bayesian inference. A lot of topics are there in stage 2.
Okay.